Hi guys, in this tutorial we'll be learning how to implement the registers in VHDL using ModelSim. So before going with the VHDL, I would recommend you to read this article so that you'll get to know the basics of registers. So basically, a register will have it's a sequential circuit. So every sequential circuit will have an clock signal. So each register has a clock signal, the data input, the data output, and the write and the reset signal. The write signal is for loading the data into register, whereas the reset signal is to reset the values of register. So the register size can vary from systems to systems. Some may use a 4-bit register, some may use an 8-bit register, some may use an 64-bit register. So it depends upon the application. In this, we are gonna just use an 8-bit register. So if you know how to design 8-bit register, we can design we can change its data bit sizes. So coming to this clock write and reset signal, so this, since it's a sequential circuit, it will get updated only if during the positive clock cycle. Just take a look at this table. So when the clock is 1, like it is positive, and write is also positive, then the data will be loaded. Say if its clock is 0 but write is 1, that will not get loaded because the clock has been 0. So in order to data to be loaded, both the clock and the write signal should be active, which means it should be 1. And for resetting, it should be that the clock should also be 1 and the reset value should also be 1. And make sure that when you reset the values, when you try to reset, make sure that you assign write signal as 0, because in that particular instance we don't need to write those values, we need to reset it. So for resetting these values, just make sure that you assign write as 0 and reset as 1, so the data will get resetted during the all this loading, all this resetting values will only take place during the positive cycle, positive clock cycle. So even though, see, if for example, if clock is 0, reset is 1, data will not get resetted because the clock has not been active. So since it's a sequential circuit, there will be some time delays because it's a clock circuit. It will have some, say, 100 picoseconds delay for getting updated, but it will get updated during the next clock cycle. So just read through this article. Let's see how to implement this in VHDL. So I have declared the libraries here, and then I have declared the entity, and we have 5 signals, right? We have a signal input, data input port, a write signal, a reset signal, a clock signal, and an output signal. So this is with respect to the entity. Next, we are coming to the architecture. Like regarding the architecture, um, the entire process is depends upon the clock. So first we have to give the if conditions based on the clock. So what we're doing is we have to just process the clock. So we are starting with processing of the clock. So if rising edge of clock, which rising edge is nothing but the point where the clock's signal is 1. That's the meaning of rising edge of CLK. CLK is nothing but our clock signal, which is I mean declared here. And if write is 1, we have to load the data. So what we're going to do is we are going to map the output to the input port. Yes, whatever input that we give should reflect on the output port. So that's what we are given. If write is 1, output is nothing but the input signal. If reset is 1, then the output should be resetted to 0, 0, 0. That's what I given here. So it's reset 1 condition and the write condition. Since we have used 2 if, there's 1 if here, second if here. So since we have used 2 if, we have to end with 2 if. So using 2 end if and end process for this process, and we are terminating the architecture. So let's simulate this. I already compiled this code, so just I'm start simulating it. So just click OK and get add wave. Say I'm going to give input as 8 ones, 1 2 3 4, 5, 6, 7, 8. Okay. As far as now, say I'm not giving a right signal. Let it be undefined. I don't need reset now. Okay. For clock, just right click it, choose the option clock and click OK. Now run it. Now you can see that though my data input port has some input, the data output has not been reflected. You know why? Because the right signal is undefined. We have not given the value for right signal. Only if we give a value for right signal, we'll be able to do that. So now click this and give the value as, force it as 1. Now you see that the data will get updated now. See, there's some delay, like there was a 100 picosecond delay, but during the next clock cycle it has been updated to over the next value. You can see the data output port went from 0 to 300 was undefined, but from 300 to 400 it was updated to the input value. Say I'm gonna say change another value, say 10 10 10 10. There will be some delay. Now you can see there's some delay. Can you see that? Though my input was given during the 400 to 500 picosecond, it is not getting updated during this clock cycle. It will only get updated in the next clock cycle. See, 400, the input was given during the 400 picosecond, but it got updated only during the 500 picosecond. Let's reset this value. Say I'm gonna set reset as 1. Don't forget to assign the right signal as 0. This is very important. Click OK. Now run this. Again you see there's some delay. After 100 picosecond, it will get reset to all zeros. I'm clicking run once again. See, the reset value was changed during the 600th picosecond, but the value got the data value of 600 to 700 picosecond was still 1010, but during the 700 picosecond it got changed to all 8 zeros. Let's remove the reset and let's try to load in again. Let's reset set as 0. Okay. Write it as 1. Now the input value is 1010. So during the next clock cycle, we should see this 1010 reflecting. Can you see 1010 has been come to this clock cycle? So this is how we implement a register. Try simulating different values, different scenarios, so you'll get an idea. Thank you.